halfway through the summer, and we are now working on grade 8. There are 3 sections in the grade 8 course: benchmark 1, 2, and 3. So we're going to start off with benchmark 1. There will be 2 pages and 2 videos for this with detailed answers. So looking at problem number 1, we see that we have negative 7x plus 2x minus 36 equals 24. We need to remember to always simplify each of the sides before we isolate the variable. So since we have like terms on the left side, we're going to combine those 2 variables. And now we have a traditional 2-step. We want to get rid of things being added and subtracted first. So we're going to add 36 to both sides. That leaves us with negative 5x equals 60. Divide by negative 5, divide by negative 5, and you get x equals negative 12. Number 2, we want to simplify. We can't get to these variables because of the parentheses. So we're going to distribute that 2 into both of those. We're going to distribute the 3 into both of those. So 2 times 5x is 10x. 2 times 4 is 8. 3 times 3x is 9x. 3 times negative 1 is negative 3. Now we have variables on both sides. We're always going to move the variable. It's simplified. We can't combine those. So we're always going to move the variable first. Don't move those constants first. Move the variables first. It produces a much better equation. So when we move the 9x by subtracting 9x to both sides, we get x plus 8 equals negative 3. Now we're going to move that constant over, and we get x equals negative 11. Number 3, how many solutions does the equation 1/4 times the quantity 21 minus 8x equals 5 minus 2x have? Well, what they're asking is, does the variable cancel out or not? So if we simplify this and the variable cancels out, you will have just a number statement, and that number statement will either be true or false. If it's true, then you're going to have an infinite number of solutions. If the variables cancel and you create a false number statement, there is no solution. You have 0 solutions. And then if the variables don't cancel out, and you're left with just a variable with a coefficient, that means you can solve it and you'll end up with 1 solution. So let's try this out. Let's distribute. You get 21/4 minus 2x equals 5 minus 2x. 1/4 times 21. 21's in the numerator, 4 is in the denominator. Then we multiply 1/4 times negative 8. 4 is in the denominator, 8's in the numerator. That becomes 2. And remember how I told you to move the variables first. That is the best way. When we move the variables, you're left with 21/4 equals 5. So my variables cancel, and I have a false number statement. That is false. So there is no solution. Solution. I know how to spell solution. Solution. Meaning how many solutions does it have? It has none. None is the answer to this question. Traditionally, you're going to say no solution if you have to solve it. Number 4, the vertices of a triangle are A, B, and C. Translate the triangle 1 unit left, 3 units down. What are the coordinates of the image? So let's draw that initial image. Negative 3, negative 1. This is where our A point is. Negative 1, 1 is where B is. And C, which is 3, negative 1, 2, 3, negative 1, is here. So we have our object, our triangle, and we're going to translate it each point 1 unit left and 3 units down. So 1 unit left, 3 units down. 1, 2, 3 is going to be where A prime is. 1 unit left, 1, 2, 3 down is where B prime is. 1 unit left, 1, 2, 3 is where C prime is going to be. So A prime is going to be negative 1, 2, 3, 4, 1, 2, 3, 4, negative 4, negative 4. B prime is going to be 1, 2, 1, 2, negative 2, negative 2, and C prime is going to be 1, 2, 3, 1, 2, 3, 1, 2, 1, 2, 3, 4. So 2, negative 4. And that's one way of doing it, and that's doing it on a graph if we wanted to show it. If we didn't do it, we'd know that A, or our point, let's not do A, our point xy, x comma y, is going to be translated. So my x value is going to be minus 1, and my y value is minus 3. So if I take each of those values, this is point A is negative 3, negative 1. If I take that x value and plug it into this equation, this template, it should give me what my new point is, which it does. So A prime became that. So that's another way to do it, is you can use this little template that represents the translation. Number 5, the vertices of a triangle are negative 3, negative 1. 1, 2, 3, negative 1, that's point A. Negative 1, 4, 1, 2, 3, 4. That's B. And negative 1, negative 2. And that's point C. Let's make sure I did that correctly. Yep. Let's connect the dots. Okay. And now we're going to reflect it over the y-axis. So this is my y-axis. I'm going to reflect it over. So if I had a line, an axis of symmetry along the y-axis, my new point would be B prime would be this, C prime would be this. I'm going to move that old C value somewhere better. That's where C is. And now let's reflect that is 1, 2, 3 away. So it's going to be on the same 1, 2, 3 away. And that is going to be A prime. And that's weird. Good. So there is my new translated or reflected triangle. And we'll connect the dots here. I don't know if we connected the dots on the other one, did we? No, we did not connect the dots. So that's what it looks there. Good. So what are those points? Those points, those new points. A prime is going to be 1, 2, 3, negative 1. B prime is going to be 1, comma 4. And C prime is going to be 1, comma negative 2. So again, if we wanted to write an equation for every xy, the translation is just going to be the opposite of x comma y. So notice if we take that point, if we take our 3, negative 1 and translate it, that's negative 3, negative 3. Negative 3, negative 1 is our original point, sorry. You would get 3, comma, plug in negative, right? The opposite of negative 3, comma, negative 1. And that produces 3, comma, negative 1, which is our reflected point. Number 6, vertices of a triangle are A is negative 2, negative 3. B is negative 2, 1. And C is negative 1, 1. Ooh, that's pretty close. Those are not fun. And that's C, sorry, that's C. So let's connect it. Okay, and now we're going to rotate the triangle 90 degrees counterclockwise. So we're going to rotate it around the origin, and what are the coordinates of the image? So if we rotate it 90 degrees, let's do this. So I always like to take it off of here. That's pretty thick. And then if you create a 90-degree angle, that's going to give me my new point. So that's going to be C prime. And if we did a line to B and then did it 90 degrees, that would be here. Okay, so that's the idea behind rotating it. And this is going to be, B prime is going to be here. And then A prime is going to be rotated from here to out to here. And that's going to be, I think that's going to be, no, that's not where it is. It's going to be, this is B prime. So it's going to be here, right? I think it's going to be right here. And the way that we do that, A prime, that's too far out. It's one off. It's going to be here. And if we drew a red line, you'd notice it's still 90 degrees. So if we connect those dots, you get that same shape, just rotated 90 degrees around the origin. And so my A prime is going to be, what's that? 1, 2, 3, 1, 2, 3, negative 2. B prime is going to be, B prime is negative 1, negative 2. And C prime is going to be negative 1, negative 1. Okay, so how do we do that? What is the translation? Remember how we have a translation for every point? Well, when you rotate it 90 degrees, what you're going to do is you're going to have the opposite of your y value and your x value. Yeah, it's kind of crazy how that works. So if we take our first point, which is negative 2, negative 3, and we take the opposite of my y value, the opposite of my y value, and my x value, which becomes 3, negative 2, does that get my my rotated point? Yeah, it does. So that is very technical. You got to do a lot of examples and a lot of practice problems to completely understand this. Doing it one time is just not enough to be proficient and to master this. So this is something that you need to do, 30 problems in order to be good at it. All right, number 7. So number 7 says triangle DEF is the image of ABC after a 180-degree rotation around the origin. ABC is scalene, is the measure of angle C equal to the measure of angle F. Now, we know that when triangles are similar, DEF, the corresponding sides and corresponding angles, are congruent. That's the definition of similar. So, and similar is we use this sign. It's a little squiggly for similar. So D corresponds with A, E corresponds with B, F corresponds with C. So C and F, yes, they are still congruent. That is a rule, that is a understanding of similar triangles. Is the length of side AB equal to the length of side EF? So again, we can say triangle ABC and triangle DEF. So when we talk about side AB, we're actually talking about side DE, not EF. So no, they are not equal to, AB is equal to DE. So corresponding sides, corresponding angles, and definitely make sure if you don't know that to go on to, you can go on to Khan Academy, you can go on to a number of support things online to work on those things. You can use Big Ideas. I know you still have access to Big Ideas this summer. So you can go into the 8th grade part and go learn that material.